Okay, so number 85. A child in danger of drowning in a river is being carried downstream by a current that flows uniformly with a speed of 2.0 meters per second. The child is 200 meters from the shore and 1,500 meters upstream of the boat dock from which the rescue team sets out. If their boat speed is 8.0 meters per second with respect to the water, at what angle should the pilot leave from the shore to go directly to the child? Okay, so this problem is going to be in a couple different parts. We're going to start with, first of all, just what we know. We know the velocity of the child is 2.0 meters per second, and we know that the velocity of the boat with respect to the water is 8.0 meters per second. And we're trying to find some angle theta that the pilot needs to use to leave the shore to intercept the child. And so make sure your calculators are in degree mode for this section. So we're going to do this in two parts. So part one is going to be in the river's frame of reference. So we need to find the x and y components for the velocity of the boat. So we're going to start off using the distances that we know, the 200 and the 1,500. We're going to take tangent of some angle x here is equal to 200 meters over 1,500 meters. We're going to solve for x. So tangent inverse or arctangent is 200 meters over 1,500 meters. And so x is going to be equal to 7.5946. And so we're going to use this and plug it into our v of x and v of y equations. So we know that v of x is equal to the velocity of the boat times cosine of x. And so we're going to plug in the velocity of the boat and x here and get 7.929. And the y component is equal to the velocity times the sine of x. And so we're going to plug that in and we're going to get 1.057. And for the second part of this frame of reference, we're going to find the velocity of the child with respect to the boat. And so the velocity of the child in respect to the boat is equal to the x component of the boat velocity minus the velocity of the child, which is 7.929 minus 2.0, which equals 5.929. And the second part is going to be in the boat's frame of reference. And so we're going to find theta for the boat's angle of departure. And so tangent theta here is going to be equal to the vertical or y component of the velocity of the boat divided by the velocity of the child in respect to the boat. And so we're going to have tangent theta is equal to 1.057 divided by 5.929. Theta is equal to the inverse of tangent of 1.057 divided by 5.929, and we're going to get theta is equal to 10.108 degrees. And so our learning goals for this particular question is relative motion and practicing our knowledge of reference frames. For this particular problem, we needed to understand the relationship between the two reference frames of the river and the boat, and how to solve for different values within these two reference frames and how to really relate them together. So thank you very much, and I hope you have a lovely day.